Director from the Animal Science Department. Grace?
We'll go ahead and get my screen shared here. Great. Okay. So hello, and thank you for that introduction. My name is Grace Jakes, and I'm a student in Animal Science and Global Resource Systems. As Dr. Tarjay said, my research mentor is Dr. Lance Fongar in the Department of Animal Science. And today, my presentation title is The Effects of Dietary Bacillus Aptilis on Postpartum Metabolism and Production Parameters in Transition Dairy Cows. So to start out with today, I want to kind of define what the transition period is in dairy animals. So the transition period is generally defined as the 3 weeks surrounding partition or calving. And it's actually considered one of the most critical phases in a cow's life because of the significant physiological changes associated with the period. Cows are subject to a multitude of stressors, challenging homeostasis, actually in addition to just the stressful event of calving. And that includes the transition to lactation and infectious challenges and also metabolic disorders. So actually, about 50% of cows experience some major infection or metabolic disorder in this period. And cows that cannot recover well from these challenges can be culled, and milk production is lost because of this. This is actually a sustainability and welfare concern. A welfare concern for the cow because if she's sick, that's not as good of a welfare outcome. And then sustainability because of the loss of milk and also the resources that are invested in a cow that won't be used in the future and the cost to the producer to replace that animal. The dairy industry has invested a lot of time and resources into trying to manage this transition period better, but there's still a lot of room for growth. So one of the key reasons that the transition period is so hard on the cow is because of her energy requirements in this period. So she has a tremendous increase in energy demand. And this is because of two things. One, she's supporting that growing fetus to the last stages before she calves. And then also she's preparing for milk production. The thing is, as she nears calving, she's actually going to have reduced dry matter intake or reduced feed intake. And this results in what's called a negative energy balance, where she is using more energy than she's actually capable of consuming. And that can result in, she'll lose a little bit of weight in this period. But generally producers, dairy farmers and nutritionists try to kind of combat this by feeding a higher starch diet, which will have more energy for her. This can result in other impacts down the road though. And this includes hindgut acidosis, which is somewhat common in this period. This is where starch is not fully fermented in the rumen, and it actually passes all the way into the large intestine, where it's broken down into volatile fatty acids. And these volatile fatty acids, of course, as an acid, will reduce the pH in the hindgut. The problem with this is that it can result in damage to the intestinal epithelium and result in increased intestinal permeability to bacteria and toxins. And this can result in what's been termed leaky gut. So moving forward, postpartum inflammation is often associated with different transition period issues. This includes infectious challenges and metabolic disorders, but it's also been observed in seemingly healthy cows. And it's believed that all cows in the transition period actually do experience higher levels of inflammation. Inflammation generally originates in 4 key areas, and that includes general or sterile. And general or sterile, I want to kind of break this off from the other 3 because it is unique from the other 3 in that it isn't associated with a pathogen specifically. I think the best way to relate it is in the human world, either arthritis or when you hit your thumb with a hammer. Both of those result in inflammation in the body, but it's not because of a pathogenic or infectious challenge. These other three are due to infectious origin. So in the uterus, we generally term that metritis. In the mammary gland, we term that mastitis. And in the gastrointestinal tract, as I mentioned before, leaky gut. Now, dairy farmers tend to try to manage these infectious challenges and the inflammation associated with that through the use of antibiotics. But there is a general need to reduce antibiotic use in animal production, both for sustainability purposes and also consumer interest in having fewer antibiotics used in livestock production. So our hypothesis is that quite a bit of the inflammation in the transition period is due to this leaky gut. And so if inflammation is caused by leaky gut, if we're trying to reduce antibiotic use, then how can we do this? And this is where Bacillus Aptilis comes in. So Bacillus Aptilis, or also called clostat in industry, is actually a bacterial direct-fed microbial. And so it was originally isolated from the intestines of healthy chickens. And in poultry, it's been reported to reduce enteric pathogens, a number of them. In ruminant animals, it actually is fed as a spore and bypasses the rumen. And then it's activated by low pH and bile salts in the small intestine. It's been shown in rodent models to reduce inflammation and actually increase intestinal epithelial integrity. And that's was shown in, like I said, in rodent models. And so our hypothesis was to evaluate the effects of Bacillus Aptilis on postpartum metabolism and production parameters in transition dairy cows. For this trial, we had 49 pregnant Holstein cows that started the trial, and we assigned them to one of two dietary treatments. The first was our control treatment, and so that was 13 grams per day of calcium carbonate added to the diet. And then the second one was our CST or clostat, and the Bacillus Aptilis, and we did 13 grams per day of that as well. And then cows were fed respective to their treatment, starting from day 21 before they're expected to calve, and then going through 63 days after they calved. And then cows on this trial were milked twice per day. Moving into sample collection, we collected dry matter intake data using the Kalin-Brodbeck feeding system. We also collected milk yield data every day, and then milk composition, we collect milk samples for that twice weekly for analysis. Then blood and fecal pH we collected before the cows calved, about 14 days before they were expected to calve. And then we also collected blood and fecal pH on days 3, 7, 14, and 28 after they calved. Moving into the results, first what I want to do as I kind of set up my graphs before I start. So on the x-axis, you can see I have my time variable represented, and so that's going to either be in week or day. And then on the y-axis, you can see the variable of interest. And so in this case, looking at milk yield, we see that that's in kilograms per day. And then I want to kind of set up, so we have our control treatment is going to be represented by the solid black line, whereas the CST is going to be represented by the red dashed line. So when we look at milk yield, what we saw was that the CST cows actually had an elevated milk yield relative to the control, and this was by about 2.2 kilograms per day. And for those who aren't as familiar with metric terms, that's about 5 pounds increase per day. And next, moving into dry matter intake, we really didn't see a difference between the control or CST cows, but we did see a time difference. And I want to highlight this because this reflects what we would expect in the transition period. So as a cow starts milk production after she calves, she's going to have reduced feed intake, but then as she acclimates to the transition period and to lactation, begins to produce more milk, she's going to have an elevated dry matter intake. On this other side here, we see feed efficiency, and so feed efficiency actually was elevated in our CST cows relative to control. And this makes sense because dry matter intake was not different between the two, but we did see an elevated milk yield. And so that means that they are producing more milk for the same amount of feed intake. And this increase was about 7.1%. So moving forward, looking into the milk components, we saw that milk fat yield, milk fat percent, milk fat yield, and milk protein percent were not different between treatments. But we did see an increase in milk protein yield, and that was by about 5.4% increase. And this kind of makes sense when we think about, so our total milk yield was increased. It would make sense that if our milk protein percent were the same, then our total milk protein yield would also be different. Moving into fecal pH, we saw a weak tendency for fecal pH to be elevated in the CST cows relative to control. And then we also saw a bigger difference on day 7. And so we did a post hoc analysis on that. And for the post hoc analysis, we saw a fecal pH increase in the CST cows relative to control of about 0.31 pH units. So moving into our blood analysis, we looked specifically at our glucose and non-esterified fatty acids, and we did not see a treatment difference between them, but we did see a time difference, and I want to highlight this as well because it reflects what we are expecting to see in the transition period. So you would expect to see in the transition period elevated levels of non-esterified fatty acids as the cow is trying to mobilize fat from adipose tissue in order to make up for the energy that she's not getting in her diet, and then also decreased levels of blood glucose because she's not able to get that glucose from her diet. Okay. And then, so in conclusion, CST supplementation increased milk yield, and this actually has some economic benefit. So when we look at 2.2 kilogram increase, or about a 5-pound increase in milk yield, that doesn't sound like a lot, especially compared to like the size of a cow and how much she is producing every day. But it is when we think about, just in the course of our trial, for the 63 days that the cows were milking, for those 24, we saw an increase of profit in the CST cows. It would have been around $1,500. When you relate that to the average dairy farm in Iowa, around 350 cows, over the course of an entire lactation, that 2.2 kilogram, 5-pound increase in milk yield could have a total profit of about $112,000. So that's pretty significant for a dairy farmer. When we look at improved feed efficiency, the key thing here is sustainability. So we're thinking about, we're trying to feed the more people, growing global population with the same or fewer resources. And so looking at improved feed efficiency, we see that we have more and increased milk yield for the same amount of feed intake. So that's a very positive thing. When we looked at increased milk protein yield, the key here is that we want to see an increase in milk yield paired with an increase in a similar amount of nutrients in that milk. So we don't want to see milk that has reduced percent protein, essentially. And another component to this is when we think about the price that dairy farmers get for their milk. It's important because that's what final price is based off of, is that protein yield and that fat yield. Finally, we saw an increase in fecal pH on day 7. And this kind of aligns with our hypothesis, where that decrease in fecal pH in the hind gut can impact production parameters in our dairy animals. And so just future directions for this study would be to look at our inflammatory biomarkers, and then also our fecal parameters, including the amounts of VFA and starch content. And so those would be to see, is the Bacillus Aptilis product actually reducing the inflammation that we're seeing in the transition cows, or is it just impacting our production parameters? And then for the CST product in general, just seeing what would happen if it's fed for the whole lactation. Would it impact, would we see about a 2.2 kilogram increase throughout the entire lactation? Or is it just for this transition period that we're seeing those improvements? As I conclude, I do want to acknowledge people who have helped me to get here today. The first one is Brady Gates. I'm Brady has helped me a lot. Obviously, he's the project manager for this trial, but he taught me a lot about data analysis, how management, blood analysis, and he helped me put in a significant amount of time helping me prepare for this presentation as well. I want to thank the Vanguard Lab Group, especially Megan and Beta, who helped me prepare the abstract for the symposium. Samantha Lay, who's our lab manager, and she taught me a lot of my initial laboratory skills. And then the ISU Dairy Farm was where we conducted this trial. And finally, project funding support from Chem Industries Incorporated. And then I also want to thank my research mentor, Dr. Lance Baumgard, for giving me the opportunity to complete this research. And I learned a lot from him and his research group. This concludes my presentation. Are there any questions as I close?
Grace, and we're only taking questions from those who are in the audience, which is literally three of us. I do have a question for you, Grace. Why is calcium carbonate a good control for a study like this? Why calcium carbonate?
Yeah, so the question was, why is calcium carbonate a good control for this study? So actually, the calcium control is kind of the carrier for the Bacillus Aptilis product. So there's actually very, very little Bacillus Aptilis product that the cows are actually receiving, even in that 13 grams that we gave. And so we wanted it to be kind of a similar composition. So the difference was only in the Bacillus Aptilis.
Okay.
Thank you for that question. Other questions?
Any questions? Okay. So is protein, because the difference, you saw a difference in protein and protein rather than not fat or other things.
Yeah.
Is protein, and I guess I'm asking, is that part of milk component pricing, or is it so this could have an impact on milk component pricing, right? Because of higher protein content.
Exactly. So the clarification was if milk, since we saw that increase in milk protein, if it would have an impact on milk component pricing. And yes, that's kind of the key thing here is that it would have an impact there.
Okay, so that was your financial analysis there. Okay.
I have one question that nobody's asking me at ADSA is based on the financial, you put some numbers up there, which was great. Would you feed this product if you were a dairy farmer or a nutritionist?
Yeah, so the question was, if I were a dairy farmer or a nutritionist, would I feed this product? And yes, I would feed this product because thinking about how much it costs per cow per day to feed the product, it's about, I believe, 4.5 cents to do that. It's definitely going to, doing the math there, it's going to be very profitable still, especially for our herd the size of 350. So yes.
Grace, your cows were essentially healthy cows, right? Mm-hmm. So has anybody looked at it in a diseased cow? Would this product also help?
Yeah, so the question was, has anyone looked at this product in diseased cows? Our cows were essentially healthy. And so no one has done that looking at transition cows specifically. However, there has been some research trials looking specifically at beef feedlot steers that were challenged with E. coli. And there's mixed data on that. The challenge is to get the animals sick enough that you can see like significant difference. And then also a lot of what they were looking at was presence of E. coli like in tissue. And that is kind of a challenging thing to see the connection there. The nice thing about transition cows is you can see like very, very immediate like differences in milk production and those types of things. So I think that there's a lot more research that's warranted, especially in dairy cattle to see what the implications are.
Mm-hmm.
Thank you.
Okay.
Are there any other questions? All right, thank you.
Well, everybody watching, please give Grace a virtual round of applause. Thank you. And this is going to conclude this session. This is the only paper presented during this session. I want to encourage everyone to try to hop on other sessions of the undergraduate research and creative expression symposium. So thanks a lot for joining.